Hello guys, welcome to another video here on HTTP in detail, and this is under the Web Fundamentals learning part on Tryhackme. We've covered how the web works model, introduction to web hacking, Bob sheet, and web hacking fundamentals is where we are right now. So today we'll be treating HTTP in detail, and here we're going to learn about how you request content from a web server using the HTTP protocol. Without further ado, let's jump right into task 1. What is HTTP or HTTPS? HTTP, which stands for Hypertext Transfer Protocol, is what is used whenever you view a website. It was developed by Tim Berners-Lee and his team between 1989 to 1991. HTTP is the set of rules used for communicating with web servers for the transmitting of web page data, whether that is the HTML you're looking at, images, videos, etc. Now, what is HTTPS? Now, this is the secure version. It's called the Hypertext Transfer Protocol Secure. Now, HTTPS is the secure version of HTTP. Now, HTTPS data is encrypted, so it not only stops people from seeing the data you are receiving and sending, but it also gives you assurance that you're talking to the correct web server and not something impersonating it. Now, let's answer some of the questions. What does HTTP stand for? Just like we saw above, it's the Hypertext Transfer Protocol. Let's hit submit and that should be correct. What does S in the HTTPS stand for? It's secure, protect your data, encryption, secure. Now, on the mock web page on the right hand side, there's an issue. Once you found it, click on it. What is the challenge flag? So we have Tryhackme, we have tryhackme.com, but this is not the safe type. It's the HTTP, not HTTPS. So I believe it's this padlock sign. Once you've clicked on it, you got the flag. So let's copy that. Tryhackme invalid HTTP certificate. Now let's paste that and hit submit, and voila, we're done with task 1. Let's head on to task 2, requests and responses. Now, when we access a website, your browser will need to make requests to a web server for assets such as HTML images and download the responses. Before that, you need to tell the browser specifically how and where to access these resources. This is where URLs will help. Okay, now what is URL? Uniform Resource Locator. If you've used the internet, you've used a URL before. A URL is predominantly an instruction on how to access a resource on the internet. The below image shows what a URL looks like with all of its features. It does not use all the features in every request. So now we have what we call the scheme. The scheme, this instructs on what protocol to use for accessing the resource, such as HTTP, we have FTP, we have SSH, and so on and so forth. FTP, which stands for File Transfer Protocol. If you click on this, it's basically a protocol designed to help the efficient transfer of files between different and even non-compatible systems. It supports two modes for file transfer, which is either binary or ASCII. Now the second here is the user. A user, usually most times you might not see this one here. Some services require authentication to log in. Now you can put a username and password into the URL to log in. Alright, so it's username, then colon password. Then the next would be the host name. Host, this is the domain name or the IP address of the server you wish to access. Okay, now the next is the port. The port that you are going to connect to, usually port 80 for HTTP and 443 for HTTPS, but this can be hosted on any port between 1 to 65,535. Okay. All right, the next will be the path. Now the path is basically the file name or location of the resource you are trying to access. Okay. Now next is query string. The query string just begins with a question mark right here. The query string is more like extra bits of information that can be sent to the requested path. For example, /blog (ID = 1) will tell the blog path that you wish to receive the blog article with the ID of 1. So basically that's what the query string does. And lastly, fragment. This is a reference to a location on the actual page requested. Okay, now this is commonly used for pages with long content and can have a certain part of the page directly linked to it. So maybe if we are scrolling down and maybe this example request under this page here in HTTP in detail, we could have that particular fragment embedded in the URL, so we can just go straight to exam request. Okay, so more or less that's what fragment is. It's commonly used for pages with long content, and it can have the certain part of that page directly linked to it, so it is viewable to the user as soon as they access the page. Now let's go into the next thing here, making a request. It is possible to make a request to a web server with just one line, which is get /http:/1.1. But for a much richer web experience, you will need to send other data as well. This other data is sent in what is called headers, where headers contain extra information to give to the web server you're communicating to. So but we'll go more into this in the header tags. Okay, so for now let's explain this particular request here. We see we have get /http:/1.1. The host is tryhackme.com, the user agent is this, and the referrer is this. Now to break down each line of this request, the first one here is this request is sending the get method. More on this in the HTTP method tags, which you're going to see soon. This request is basically requesting the home page with a / and telling the web server we are using HTTP protocol version 1.1. Line 2 is we tell the web server we want the website tryhackme.com. Line 3, we tell the web server we are using the Firefox version 87 browser. Okay, Firefox /87.0. And lastly, we are telling the web server that the web page that referred us to this one is the https://tryhackme.com. Now lastly, line 5, HTTP request always ends with a blank line to inform the web server that the request has finished. So this one is always important. There's always a blank line. Now example of the response, this is the request. So now the response would look like this. To break down this request, the response, line 1 is now like HTTP 1.1 is the version of the HTTP protocol the server is using, and then followed by the HTTP status code, in this case 200 OK, which tells us that the request has completed successfully. There are other status codes which we will see soon. Now line 2 basically is telling us, which is this. All right, the server, it basically tells us the web server software and version number. If you notice, it wasn't in the request, it's only on the response because we are getting the response from the server. Now the line 3 here is date. The current date, time, and the time zone of the web server. Line 4, the content type. The content type header, which tells the clients what sort of information is going to be sent, such as HTTP, such as HTML, images, video, PDF, XML. In this part, we are looking at this as text or HTML. And lastly, line 5, which is line 5, which is the content length. It tells the client how long the response is. This way we can confirm no data is missing. So content length 98 in this case. Line 6 here says HTTP response contains a blank line to confirm the end of the HTTP response, as you can see here. Same thing with the request. Alright, and then lastly, line 7 to 14 is the information that has been requested in the instance. In this instance, we're looking at the home page, so this is just basically the information that was requested. Okay, let's answer some question. What HTTP protocol is being used in the above example? It's the HTTP:1.1. That's version 1.1. Submit, and that's correct. What response header tells the browser how much data to expect? Remember, content length, it tells the client how long the response is, which is basically how much data to expect. So we just copy this. It's called the content length. All right, it tells the browser how much data to expect. Submit that, and correct. That brings us to the end of task 2. Let's head on to task 3. Task 3, HTTP methods. Now, HTTP methods are a way for the client to show their intended action when making an HTTP request. There are a lot of HTTP methods, but we will cover the most common ones, although mostly you will deal with the get and the post method. Now, the get request, this is used for getting information from the web server, just like get to retract information from the web server. Post request, this is used to submit data, which is submitting data into the web server and potentially creating new records. Okay, now put request, this is used for submitting data as well, but in this case to update the information that was previously already posted into the web server. And lastly is the delete request. This is used in deleting information or records from a web server. Now let's answer some questions. What method would we use to create a new user? New user is called post. You hit submit, and that is correct. What method would be used to update your email address? To update, we're going to use put. Submit, correct. What method would be used to remove a picture you have uploaded to your account? That would be the delete method. Submit, correct. What method would be used to view a news article to get information from the web server? That would be get. Hit submit, and that is correct. End of task 3. Let's head on to task 4. Task 4 here is HTTP status codes. Now, we're going to view site, so while it's loading, I'll go ahead. Now, the HTTP status codes, in the previous tasks, you learned that when a HTTP server responds, the first line always contains a status code. Like we saw previously, it had a status code of 200 OK, which means successful. Now, these status codes are informing the client of the outcome of their request and also potentially how to handle it. Now, these status codes can be broken down into 5 different ranges, which we're going to see right now. The first is range 100 to 199. It's the information response. These are sent to tell the client the first part of their request has been accepted, and they should continue sending the request of their sending the rest of their request. These codes are no longer very common. Yes, we normally don't get this anymore. Now, 200 to 299, success. This range of status code is used to tell the client their request was successful. We saw that in the previous example, in the previous task. Now, 300 to 399, these are used to redirect the client's request to another resource. This can be either to a different web page or a different website altogether. Next is 400 to 499, which is client's errors. Used to inform the client that there was an error with their request. And lastly, 500 to 599 server errors. This is reserved for errors happening on the server side and usually indicates quite a major problem with the server handling the request. Now let's look at some common HTTP status codes. This was basically the range, right? Now let's look at some common ones, the status code itself. There are a lot of different HTTP status codes, and that's not including the fact that some applications can even define their own status codes. We'll go over the most common HTTP responses you are likely to come across. The first one is 200 OK. This request was completely successful. Okay, now the next is 201 created. A resource has been created, for example a new user or a new blog post and so on. Now 301 moved permanently. This redirects the client's browser to a new web page or tells the search engines that the page has moved somewhere else and to look there instead. Now 302, which means found, similar to the above permanent redirect, but as the name suggests, this is only a temporary change and it may change again in the near future. Now 400, which is what we call the bad request. This tells the browser that something was either wrong or missing in their request. This could sometimes be used if the web server resource that is being requested expected a certain parameter that the client didn't send. So it will push back this error 400 to let you know that something is missing or something is wrong. Now we have 401, not authorized. You are not currently allowed to view this resource until you have authorized with the web application, most commonly with a username and password. So if you impute maybe like a wrong username or a wrong password, you start to get this error, which is basically that you're not authorized to view this resource unless you are authorized, right? So 403, forbidden. You do not have permissions to view this resource, whether you are logged in or not, whether you have the right username and password or not. This error shows you that you have no permission to view this resource. Okay, we have that example here of 403, which means 403 forbidden. So it shows that we have no permissions to view this resource. The next is 405. 405 method not allowed. This resource does not allow this method request. This resource does not allow this method request. For example, you send a get request to the resource, or you want to create an account when it was actually expecting a post request instead. So it's an error you get to show you that this method is not allowed. 404, a very popular error message. It means that the page or resource you requested does not exist. Click on 404. This is how it looks like. Not found. The requested URL /missing.html was not found on the server. So it means that the page you are requesting does not exist or is not in the server. 500, internal service error. This server has encountered some kind of error with your request that it doesn't know how to handle properly. Okay, that's error 500. Error 503, service unavailable. This server cannot handle your request as it either overloaded or down for maintenance. 503, service unavailable. It means that maybe you can take advantage of this error message to maybe try to gain access to the server, or if you're doing a penetration test or something of that nature. So it means the server is temporarily unavailable or unable to service your request due to maintenance downtime or capacity problems. Please try again. So now we've clicked on that view site button on the right to see some of the HTTP status messages look like in a browser. So we've already done that. Now let's answer some of the questions. What response code might you receive if you've created a new user or a blog post? A new user or blog post is 201. Hit submit and that's correct. What response code might you receive if you've tried to access a page that does not exist? That should be error 401. No, it should be 404. Okay, so 404, we already saw that here. The page you're looking for does not exist. Now, what response code might you receive if the web server cannot access its database and the application crashes? So we're looking at 503. Hit submit, just like the error we saw here. Okay, error 503 means it can't access that, or it can't actually give you service your request at the moment. Now, what response code might you receive if you try to edit your profile without logging in first? That's where the error 401 comes in. Submit, and that's correct. That's the end of task 4. Let's head on to task 5. Headers. Headers are additional bits of data you can send to the web server when making requests. Although no headers are strictly required when making HTTP requests, you will find it difficult to view a website properly. Okay, common request headers. These are headers that are sent from the client, usually your browser, to the server. One is host. Some web servers host multiple websites, so by providing the host header, you can tell it which one you require. Otherwise, you will just receive the default website for the server. User agent. This is your browser software and version number, telling the web server your browser software helps it format the website properly for your browser, and also some elements of HTML. The way you access data using your phone on a particular website is different from when you're using Chrome, you're using Firefox, or you're using your computer to access a particular website. So it needs to send a header called the user agent to let it know the browser type you're using and a version number, so it can be able to generate the exact format that is proper for your browser. This is some elements of the HTML, JavaScript, and CSS are only available in certain browsers. So that's where the user agent is important and where it comes in. Now, content length. When sending data to a web server, such as in a form, the content length tells the web server how much data to expect in the web request. This way, the server can ensure it isn't missing any data. Now, accept encoding. This tells web server that what types of compression methods the browser supports, so that the data can be made smaller for transmitting over the internet. That's accept encoding. Cookie. Data sent to the server to help remember your information. See cookie tags for more information. We're going to see that soon. Common response header. These are basic common request headers. Now, common response headers, these are headers that are returned to the client from the server after a request. One is set cookie. Information to store, which gets sent back to the web server on each request made after, so it can be able to recognize that, oh, you're coming back again, instead of seeing it as a new particular request. We're going to see that in the cookie tags. Cache control or cache control. How long to store the content of the response in the browser's cache before it requests it again. Alright, now we have content type. This tells the client which type of data is being returned, that is HTML, CSS, JavaScript, images, PDF, videos, etc. Using the content type header, the browser then knows how to process the data. Now, content encoding. What method has been used to compress the data to make it smaller when sending it over the internet? Let's answer some questions. What header tells the web server what browser is being used? The popular word, user agent. Okay, it submits, and that's correct. What header tells the browser what type of data is being returned? What type of data is being returned? That is the content type. Tells the client what type of data is being returned. So let's just copy that. Okay, content type. All right, paste that, hit enter. Correct. What header tells the web server which website is being requested? We're looking at host. Hit submit, and that's correct. Let's head on to task 6. Tag 6 is cookies. Click on view sites and let's wait for that to get there. Okay, now you've probably heard of cookies before. They are just a small piece of data that is stored on your computer. Now, cookies are saved when you receive a set cookie header from a web server. Then every further request you make, you will send the cookie data back to the web server. Now, because HTTP is stateless, doesn't keep track of your previous requests, cookies can be used to remind the web server who you are, some personal settings for the website, or whether you've been to the website before. Okay, now let's take a look at this as an example HTTP request. Okay, it's quite a long one. Okay, let's start here. So first, you send a GET request with HTTP 1.1. The host is cookies.thm and the user agent is this. So when you send this is basically the client requesting the web page from http://cookies.thm. Next, you get a response from the server. This server responds back with a simple web page with a form asking for the user's name. So it asks, this is the response you get, although you can see 200 here, which means it was successful, but it's also requesting for user's name. Now again, you use post. You're not using get this time. You use post when you want to create a name or when you want to create a new data. So here we say the name is Adam. The client sends back the form with the name set to Adam, and then you get a response back with a set cookie. Remember, when we have a set cookie, is a header that is, a response header. Okay, now this server responds with a set cookie header telling the client to save the data name is equals to Adam. Right, now lastly, you send a GET request again, and whenever you now send a GET request again to for cookies.thm, on the next and every further request the client sends, the cookie data sends the cookie data back to the server. You will always see a cookie name is equals to Adam, and in this case you always get a response. The server then sees the cookie data, and instead of displaying the form, it displays a welcome back message instead. Okay, so basically that's how cookie works. Cookies can be used for many purposes, but are mostly commonly used for website authentication. The cookie value won't usually be a clear text string where you can see the password, but a token, unique secret code that isn't humanly guessable. Now, viewing your cookies. You can easily view what cookies your browser is sending to your website by using the developers tools in your browser. If you're not sure how to get to the developers tools in your browser, click the view site button on the top of the text for how to guide. Look at basically it's open, and once you have a developer tools open, click on the network tab. This tab will show you a list of all the resources your browser have requested. You can then click on each one to receive a detailed breakdown of the request and response. If your browser set a cookie, you will see this on the cookies tab of the request. Now, which header is used to save cookies to your computer? Before we answer that, we have Firefox. Basically, if you hit the three dots here, like the one we see here on my tab, if you scroll down to more tools, you would see web developers tools, and then there you can be able to see, let's give an example. This is Firefox, more tools, click on web developer tools, or the shortcut which is Ctrl+Shift+I. Then if we click on network, we'll be able to see all, like the example. This is a post request from previously. You can see more options are coming. We have this might be a GET request, and then if you click on any one, for instance this post request, here we can see all the headers, cookies, requests, response, and so on and so forth. So basically that's it. Now you can check for Chrome, Safari, Edge, Internet Explorer, and so on and so forth. Now let's answer the question here. Which header is used to save cookies to your computer? And that should be set cookies. Sorry, I'm using all caps, and that's correct. Set cookies. Now let's head on to tag 7, which is the last task here, making requests. Click on the view site button on the right, and then this is an emulator for making a demo HTTP request using what you've learned from the above tasks. You can use it to complete the questions below. Make a get request to /room. Tour guide. Would you like to take a guided tour to learn more about how to get started? Let's start. Here is where you get the methods to change your HTTP request methods. You can check them here. We have guest, post, put, delete. Next, we have where we have our uniform resource locator, the URL, where we can change the URL. Next, we have where we can send the request, either the get, post, put, or anyone. Here's where we'll click it. And lastly, we have the parameters. We can set the parameters here, like the ID number and so on. Hit done and we're good to go. So let's start with the first question. It says make a get request to /room. This means we are getting our method here is get already, http tryhackme.com. we're looking for /room. So let's type in ROOM. Is there a parameter to set? No, we just hit. If you notice, this is already reflecting here. Yet no, so we hit go, and this was the request and this was the response. And in that response we have welcome to the room with our flag here. Copy this. You see, this is how it will show on a browser. Welcome to the room, Tryhackme, you are in the room. So I'll copy that and paste here, hit submit. Correct. All right. Now next is make a get request to /blog, and using the gear icon set the ID parameter to 1 in the URL field. So we're still using the method get. We're going to basically we're looking at blog. See, get /blog, and it changed right here. And then we'll set in parameter, enter key. The key here is ID. The value here is 1. We hit save. Okay, that's all I needed. Proceed, and then we can hit go, and then we'll get the response right here with all the headers. And then viewing the blog article 1, you see THM, you found the blog. So let's copy the flag and paste that here, hit submit, and that's correct. Make a delete request to /user /1. We're going to use the delete method, and we're looking for, let's recall what we call this under the HTTP, not this part. I think it's under request and responses. Remember what we call this is the host and the domain. What do we call here? This is the path. So this is the path we have always been. I forgot to call that path. Okay, path. So we're looking to delete the path user and then user 1. So we're going to type in user. You can see delete /user then 1. Okay, and there's no other parameter. We hit go, and you can see the user has been deleted. Tryhackme user is deleted. So we'll copy that and we're going to paste that here and hit submit. Voila, that's correct. Now make a put request to user 2 with the username parameter set to admin. So we want to make a put request, which is put, and it's under user. It's going to be user 2. Parameter is, I'm going to delete this. The parameter here is username, and the value is admin. We set that and proceed, and we hit go. And as you can see, missing parameter. No, I didn't save it. So save, proceed, and hit go. As you can see, username changed to admin. So we've successfully done that. So we're going to copy that here. User has been updated. Sorry, put request is for updating. So we just paste that here, submit. And lastly, post the username of THM and a password of let me in to /login. So under the path login, we're making what method? We're looking at post method. And then parameters here, we're still going to use our username to be you're going to change this one. Okay, we just delete it here. So we have username. The username is thm. We'll save that. The next is the password. The password is let me in. All right, save that and we'll proceed. Once we've done that, we'll hit go and you're logged in. Welcome back, http request master. So that's the flag. Let me copy that, copy, and voila, submit, and that's it. Congratulations, we've completed the room. Thank you guys for studying with me. Thank you for learning with me. This was HTTP in detail. I'll see you guys in another video, and enjoy the rest of your day. Ciao.